Hello students, so today in this very first video on statistics or data handling, I'm going to first talk about data, its types, and then later on I'll cover the organization of data in more details. Right. So, what is data? You see, in our daily life, often we come across situations where we have to collect information in the form of numbers or facts. Like you see, for example, you see over here the number of students using calculators, number of brothers and sisters in your family, even the number of girls wearing bangles in your class, right? Number of buses crossing a certain road junction at a given time, even the speeds of bikes, cars and other vehicles passed along a specific highway. So you see, the numerical information or facts collected is known as data. And when was the first time it was used? It was around 1940s. You see, and the plural of datum is actually data. In Latin it means given or to give. You see, in the year 1954 a term called data processing was first introduced. Now, so that's data. Now what comes next is collection of data. So you see, a student like you, Santi, she has collected the following information about a friend's preference of sweets, right? And so she has, you see, just written the friend's name in this column, and in another column she has written the sweet preferred. So only two column data, name and sweet, okay? That's it. And so this is the column, it ends over here and then again it starts. Okay. So there are so many friends of Santi and so many sweets they prefer. Some are repetitions, like you see Nawaz, he likes cake. Mullai also likes cake. Again, Kalai also likes cake, you see. So you can get such type of idea. Even Malar Kodi, he also likes cake. So cake is common. Similarly, other pagan also likes cakes. Okay, so you see, from this data itself, if you look around and observe carefully, you can easily decide who likes which sweets. How many students like cake, say for example. So you see, this way of collecting the data helps Santi to decide what sweets to get for her birthday, because probably she is going to invite all of them, and how much sweets she must buy of each type, how much cake, how much kesari, how much laddu and all that. Okay, so you see the importance of data. So before her birthday she has collected this data so that her friends can enjoy her birthday more. Okay, now good. So what are the types of data? Well, you see, on the basis of collection itself, the process of collection itself shows that data is of two types. First is primary data and next is secondary data. So what's primary data? It basically means raw data which has been collected from the original source and has not gone any kind of statistical treatment like sorting or tabulation, nothing. Just has been collected. So there is a pool of raw data, so it has been collected by some person. So this is primary data. Say for example, list of absentees in the class, again a survey of writing habits of students conducted by a pen company. Next, the type of leaves collected by students for studying nature, right? You see, you can do even more, you can write even more examples of primary data. Now comes the secondary data. As the name suggests, the secondary data consists of second-hand information, right? This is not first-hand, second-hand. So basically, someone has collected from this pool data. Now you are going to collect from that someone. So this is your secondary data. Now it could have been collected by someone other than the user or for some other purpose. Some examples, you see. The headmaster collects the students' absentee list from the school office. The cricket scores gathered from a website. Okay, data from television and newspapers. Even the list of contact numbers from telephone directory. You have to remember that primary data is collected in person and so more reliable than secondary data. You are basically collecting from some other person, but primary data you are doing this by yourself. Okay. So now after all this comes the organization of data. Why is this important? The first question is, so we have got data and all that. That's it. Now look over here. If you want to really know the numbers, you have to you have to look every time and you have to try to make sense of everything. Suppose just from this information I ask you, how many students are there who like laddu? Or even better question, what is that sweet which is liked by the maximum number of students of Santi's class? Do you understand? To answer this, you have to make a list of what are the sweets are there, each of the sweets, how many of them are liked by each, what is the number of students which like a particular sweet. You have to tabulate, you have to find it, and finally you will get to know the answer, that what is that sweet which is liked by the maximum number of students. So this is an example of data analysis, and for that you have to organize the data, right? So you see, the data which has been collected are to be arranged methodically or basically logically, so that the information can be looked up fast whenever needed, easily and efficiently. And now we are going to use the technique of tally marks, okay, and frequency table for organizing of data. Okay, let's start.
And it becomes difficult to extract information from it. Therefore, what we need is to record and organize the data. So first, basically we have raw data. Right. Now what we will be doing is organize this raw data. And for that, first you see this example. Now Jones asked a group of 16 students to tell their marks out of 20 in a maths test, and you see overall how many students? 16 students. So these are the marks. First of all, what is the observation? Dear students, the lowest mark is 14. What's the highest? 16. So all the students are pretty decent in the examination. So see, this is just an observation from the lowest and the highest marks. Okay. Now what we are going to do is we are going to organize this data using a frequency table. So what do we do? Basically we will set up a table with 3 columns. So these are the columns: first column, second column, and then third column. Now the first column is basically the marks. Okay, you can say that this is the subject of the sentence, marks. The second column is something called tally, and then comes the frequency. Of course, the name frequency table. So this is the frequency. So how are we going to do this? Now first note what are the marks. Here if you look closely, just follow the pattern. So 14, 16, 15, 15, again 14, and so on. So effectively there are only 3 marks: 14, 15 and 16, right? Good. So I will put those 3 marks over here: 14, 15 and 16. Okay, good. Next, what you do is you count how many times 14 is there. Okay, now you will ask me, sir, how am I going to do that? Good, don't worry. We are going to use tally for that. So basically we have to read the data and make a tally. So this is something called tally. This symbol, this is a forward slash. What is this? This is a backward slash, but here we are going to use the forward slash. Now for that, first you just count how many times 14 is there. Start from here. So we will do a scanning from left to right, first line and then second line, or first row and then second row. Now here 14 we have got 1. So just as I found the value of 14 is 1, I will mark something like this, 1. Next, keep on scanning. Are there any other 14? No. Any other 14? Yes, second 14. So I mark second tally. So that's it. This is the marking. Now next, so 14 is exhausted. Next, let's go to 15. So scanning 15 1, 15 2, 15 3. So in the first row 3 times 15. So I will mark 1 2 3. Next, second row 4 5. How many? 5 overall. Now you see, so 1 2 3 is there, 4. Now I am not going to write 5 like this, but I am going to cut this group. So the fifth one is the slanting slash. So this means that we have a group of 5. So in tally, effectively a group of 5 is written like this, 4 slashes and then 1 slash cut all together. Next, let me talk about 16 marks. How many are there? 1 2 3 4 5 6 7 8 9 9. So you see, how am I writing? First I am 1 2 3 4 5. So let me write 1 2 3 4, then 5, completed. Next 6 7 8. So this is how we do the tally. Okay, next what you do, let me rub this so you understand what is happening in tally. Effectively all the groups of 5 are like this. So now we will just count. Okay, count the tally strokes for each class. That means for 14, 15 and 16, and then write the number over here. So that's the frequency. So how many are there? 1 2 2. How many are there? 5 5. Next, how many are there? One second, I think we have missed 1. This is not 8 probably. Let me see. 1 2 3 4 5 6 7 8 9. Right, there are 9, not 8. So 9. Had it been 10, we would have to do a cross. So 2 5 9. Now how many are there total? You see, just count the frequency. 16. Okay, now you see, I just did a mistake. So it is important that you scan the numbers carefully. Sometimes it can happen. We have to be careful. That's it. So this is a basic idea about, you see, tally, and then how to make a tally and then a frequency. Now you see, students, we have just seen an example right now where we have organized raw data for the case when number of data values were small. What's the total marks? How many students? It was 16. And so we decided to organize it in first column, which was marks, next column which was tally, and then the third column which was frequency. Okay, that's it. That's the basic idea. Now suppose the number of data values were not small. However, suppose the situation has been such that the number of data values would have been large. Now you will say, how large? Suppose instead of 16, the total number of students would have been 160. Okay, and again the distribution of marks would have been much more. previously in this example, we have seen that the marks varied between 14, 15 and 16, right? Now, for 160 students, again the examination was of 20 marks, suppose marks, and now this time the marks vary a lot. This is for the entire section of the whole group, and suppose there are more than 5 to 6 sections, and so there are so many types of students, and there will be marks like 2, even 12, even 18, even 9, even 3, even 5, even 17, okay, 6, 10 and so on. So you see, as a result of all this, so if we keep on writing like this, 2, next in ascending order marks is 3, next ascending order marks is 5. So what I am telling you is 160 students. So these are the numbers which 160 students have received. So suppose 5 students have received, so number of students, 5 students have received 2 marks, 8 students have received 12 marks and so on, something like this. Now if we have to follow this procedure that we have done, then we have to keep on writing the marks, 2, 3, 5, next 9, next 6, next 9, next 10, okay, next number is 12, next number is 17, okay, next number is 18, and then we have to do the tally, 1, 2, 3, 4, 5 and so on. Now you see, this would have been very cumbersome process. This will be very hard. Okay, you have to do the search every time, and this will take a lot of time, and this is cumbersome process. Now there is an even shorter process to do this, a shorter way. Do you know what is that? And the shorter process is to make groups. That means now instead of just, so here we have got 3 marks. So all the 3 marks we were doing to make the tally and frequency and all that. Now what we are going to do is we have to take how many marks were there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible marks, 9 type of students. So let us make again 3 groups, just like the previous case where we have got 3 marks. Now you will ask me, sir, how am I going to make the 3 groups? If I am able to do so, then the problem will become similar to the previous problem where the number of data values were small. Now how am I going to do that? Now in statistics or in mathematics, we call this class interval, 3 groups or 3 class intervals. This is what we are going to do. Now for making 3 groups, look at the marks. What's the minimum number? 2. What's the maximum number? 8. Right, 18, not 8, 18. So effectively we can make 3 groups, right? How? Just divide 18 by 3. And what you get? 6. So let us make each group of 6. So it will be like this. So I will do a multiple of 6. So 6 into 1, 6. 6 into 2, 12. And 6 into 3, 18. So these are the numbers, right? Now what I am going to do, the 3 groups will be 1 to 6. All the marks in the first group. So this is the first group or first class interval. Next is 7 to 12. And the third is 13 to 18. So now you see we have got 3 groups or 3 classes similar to this problem previously that we were doing. And now we are going to again do the same thing that we did previously. So instead of marks, now we will have class intervals. Okay, Now next will be your tally, and then will be frequency. So again this time we will have the three columns analysis. Now in sometimes, so this is how we have logically distributed the data. Now but there is a gap, you see, between 6 and 7. So it is better that we try to address this issue. So sometimes it is written not like this but like this. Actual meaning is 1 to 6, but they will write just like this: 1 to 6, 6 to 12, 12 to 18. Now when we are writing this, then this means that 6 will be included here, and any number after 6 will be included in this group, and any number which is more than 12 will be included in this group. So this is a continuous class or continuous group, but the meaning is just like this. So this is how we perform the mathematics of basic data organization. So basically what I have shown you in this page is how to organize data using tally and frequency when the data values are small and when the data values are large. So basic idea is, when the data is large, we have to first organize the data into groups, and then we will do according analysis using tally and frequency. Okay, so now let us look at yet another example to give you a flavor, real flavor of why do we need to group. So previously data was everywhere, now we are trying to analyze in terms of groups. Okay, so group analysis. So let us try to understand using another example. So this time Jones has conducted a similar survey on 40 students. Now examination was of mathematics, and this time the marks, maximum marks in the exam was 30 marks. And you see, so many students have received large variety of marks. There are students, you see, probably yes, only one student who have received 0. So this is the minimum mark. And also there is a student who has received 28 in the examination. So he has scored 28, maximum mark. Okay, now how am I going to process this whole information? So as I was saying, there are too many values, and it is not practical to list each value in a frequency table. Otherwise there will be so many rows and all that, and it will be very hard to analyze. So let us group. So instead of all the marks together, let us group. How we do the group? Very simple. See, the maximum marks is 30. Okay, now let us do the maths. So let us make 6 groups. Now 6 into 5, or 30 by 6 is 5. So 6 groups, each group will have 5 marks. Say for example 0 to 4. 0, 1, 2, 3, 4, 5. So 0 to 4, total 5 marks. Next 5, next 5, next 5, next 5, and similarly 25 to 29 also 5 marks. So this is how we are going to group all the 40 marks into only 6 groups. Each group containing interval, the class interval is of 5 marks. And how many classes are there? Overall 6 classes. Okay, or 6 groups, each group interval is 5. That's the basic. Now again, so let us do the analysis. So let me scan again how many students have received mark between 0 to 4. Okay, let me scan. So this is 1, 1, 1, next 2, next 3. So only 3 students. See, I have written in the form of tally only 3, and let me write down the frequency again 3. So you see, this is how we do the analysis. So as I was saying, the span of each interval here is 5, and we say the class size is 5, meaning 5 values are included in each class. So this is the actual maths. Now you see the number of classes you make is your choice. Instead of 6, you can make 3 classes. So what will be the classes? It will be this time 0 to 10, next 11 to 20, and then how much? 21 to 30. You can also do like this, do the analysis. It's possible.
That's it.
Okay, so what we have done is effectively the following. We have got this 40 data values. Fine. Now here we have seen the grouping in terms of 6 groups, and then after that group frequency table. So effectively we have organized the data in 6 groups and we have tried to analyze the frequency. Next we can do the same for 3 groups. So see the graph over here, 6 group frequency table, 3 group frequency table, even we can perform 10 group frequency table. So in this case the groups will be 0, 1, 2, then 3, 4, 5, next 6, 7, 8, next 9, 10, 11 and so on. So each group will be 3, class size is 3, 0, 1, 2. Okay, so you see these are the possibilities. Now we can also have, if this thing goes on, one group frequency table. Now tell me, is this meaningful? One group frequency table means I will just put everything in 0 to 30, then I will do the tally and then I will do the frequency. Now the thing is that this doesn't give me anything. This is just useless because I am putting everything together. This does not give me any meaningful result, whereas this is much better in 3 groups. So at least I am able to analyze the data in 3 categories, in 3 groups. Richness is more over here. Again, compared to the 3 groups, here there is even more richness. You see, we have categorized the entire data values in 6 groups. So there is more richness. You can do even more analysis. So you can even say like this, that look, this group, say for example, this 15 to 19 group, this is happening the most. So students, this group of students, they have got much more marks. But here you will find you cannot say something like this. So what I am saying to say, this is an overall average result. This is much more richer. This is trying to see the inner structure of the data values. This sees even more inner structure, even more richness you will see if you group the data into 10 groups. But again, this is even more harder to analyze. So you have to choose accordingly. How will you try to organize your data? Now, of course, this is not a good choice. One group is absolutely not good. You can make groups from overall, you see, the number of classes you make is your choice. A good number of classes is between 6 to 10. This is overall, more or less, the standard procedure. And also you see the class intervals must not overlap so that no data value can fall into 2 classes. For instance, we should not have intervals like 0 to 4 and 4 to 9. However, we can have something like this, and I will talk about it very soon. Now, most importantly, the class intervals should cover both the smallest value. So the smallest value is 0. It must be covered, and the largest value is 28. So the class intervals must cover. See, 0 is covered in this group and 28 is covered in this group. Okay. Now, associated with this concept of group frequency table is the concept of range. So, what is range? We will again come to it later on, but let me just quickly go through it. You see, the range of a given set gives us an idea of the spread of observation. Effectively, this can be determined by subtracting the smallest observation from the largest. So here the smallest observation is 0, the largest observation is 28. See, smallest is 0, largest is 28. So what is the range? 28 minus 0. So that's the range. Okay. Okay, now let me do a quick recap. So this is yet another example over here, you see. So let us observe the marks obtained by 25 students in mathematics. Now since this is maths, so most of the examples are related to marks of the students in maths. Now you see there is a large variety of marks. The smallest is 31 and the largest is how much? 88. So you again do something that we have already talked about. No, smallest is not 31. Smallest is, try to find, first scan this and try to see 28 over here. Smallest is 28. So you start writing the smallest and then the largest and then write the numbers in between. So this is how do you write the marks. Then try to find how many times they have repeated in the tally marks. Use tally marks. Next, you from the tally marks you write down the frequency. Now this is how we do this, but as you can see the table is very long, and so for convenience we make groups of observations, and this is your group frequency distribution table. Now look into the individual groups 25 to 35. You see again I am using the number 35 to 45. How is this possible? Because 35 will be included in any one of the groups. But why am I writing this? I have already talked to you about this. You see, here effectively we have formed 7 groups, 25 to 35, 35 to 45 and so on from 85 to 95. Now why 7 groups? More or less you see each of the class size, how much? 25 to 35, approximately 10. So here the class size, most of the time you have to remember the class size is either 5 or it is 10. This is what we choose. Okay. Now we have to include both the lowest and the largest. Largest is 88, so we have chosen up to 95, and we have that's why not considered 95 to 105. Why? Because there will be no data over here, so we do not include this. So we just start from here where 28 is included and we end at 95. So this is the reason. Next you see, so each of the groups is called class interval, as I have talked about, and the class intervals are written like this. Now this type of writing, the classes are called continuous classes. Now in class 25 to 35, it is important you have to understand that 25 is called the lower class limit and 35 is called the upper class limit. Now look over here. Now in each of the classes, the upper limit is not included. So this is the standard procedure. There can be others as well, but this is the standard procedure. So when I am saying 25 to 35, here 35 is not included. Now this is the standard definition that is used worldwide for continuous classes. So where is 35 included? In the next group, 35 to 45. But here again, 45 will not be included. So in a way, you see these classes, we can also write like this, 25 to 34. And 35 to 44. This is the actual meaning of this class. However, this type of writing the classes is called discontinuous classes. This is the actual meaning, but we write like this. Okay. Now there is also another concept called class mark. What is that? Basically, class mark is you add the two numbers and divide by 2. That is average of 25 and 35, which is 30. And class size, of course, we know maximum minus minimum of a class. So the class size is basically the difference between the upper and lower class limits. So here the class limit will be, class size will be 35 minus 25, which is 10. Okay, now let's do yet another example over here. So following are the marks obtained by students of mathematics. Now when you are given like this, you have to first find the first step. Step 1 is to find the minimum and maximum marks. Here the minimum is 48 and maximum is 89. So as usual we are going to do here groups of 10. So either it is 10 or 5. This is the standard procedure. So the class size, okay, is either 5 or 10. This is what we normally choose. Now here we have chosen 10. So the class intervals are, we have to include the lowest one, which is 48. So we start from 40 and end at 90, so that 89 is included. Okay, so how many groups? 5 groups, and then we write down accordingly. So this is the standard procedure. And again the frequency, and see, you have to check the total whether you have missed something or not. So total is 35. See, there are 35 students. Okay, let me talk about yet another example. So following table is showing the distribution of marks of students. So distribution of marks, number of students. Now lower limit of the class 50 to 60. What's the lower limit? 50, right? What's the upper limit? 70 to 80, 80. What is the class mark? What is the class mark of the second interval, 40 to 50? You have to just add 40 and 50 by 2, which is 45. Next, what is the class size? The class size in each case is 50 minus 40, 10, 60 minus 50, 10. Okay, so this one. So you see, this is how we do data handling.